This is SpaceTime, Series 20, Episode 23. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, Cassini's grand finale will see the pioneering probe go out in a blaze of glory. Could fast radio bursts be powering alien ships? And the latest calls to restore Pluto's planetary status. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Cassini spacecraft, which has been orbiting the Saturnian system since 2004, will officially end its mission with a suicidal death plunge into the ringed world on September the 15th this year. As part of its endgame, mission managers at NASA's Jet Propulsion laboratory in Pasadena, California, have begun sending the probe on riskier, more adventurous missions. Cassini has already begun a series of 20 passes just beyond the outer edge of Saturn's main rings. These weekly loops around Saturn, known as F-ring orbits, send the spacecraft high above and below the planet's poles. During these orbits, Cassini approaches to within 7,800 kilometres of the centre of the narrow F-ring, with its wispy and ever-changing structure. Cassini project scientist Linda Spilker from JPL says the F-ring orbits providing scientists with incredible never-before-seen views of the rings, along with the small moons and other structures embedded in them. The last time Cassini got this close to Saturn's rings was during its arrival in the Saturnian system back in 2004, and back then scientists really only got to see their backlit side. Now they've had dozens of opportunities to examine the structure of the rings at high resolutions and on both sides. Cassini's final phase, called the grand finale, begins in late April 2017. A close flyby of Saturn's giant moon Titan will reshape the spacecraft's orbit so that instead of passing outside the rings, it passes through the gap between the rings and the planet. Cassini will make 22 plunges through this gap, an unexplored space only about 2,400 kilometres wide, beginning with its first dive on April 27th. During the grand finale, Cassini will make the closest ever observations of Saturn, mapping the planet's magnetic and gravity fields with exquisite precision and returning ultra-close-up views of the atmosphere. The orbit should allow scientists to gain new insights into Saturn's internal structure, the precise length of Saturn's day, and the total mass of the rings, which may finally help to settle the question of their age. The spacecraft will also directly analyse dust-sized particles in the main rings and sample the outer reaches of Saturn's atmosphere, both first-time measurements for the mission. Cassini's mission to Saturn will finally come to its dramatic end on September the 15th, 2017. After more than 13 years of studying the Saturnian system, its rings and moons, and nearly 20 years since its launch. On that final day, Cassini will dive into Saturn, returning data about the chemical composition of the planet's upper atmosphere. It'll keep sending until the signal's finally lost. That will happen as the spacecraft pushes into thicker and thicker atmosphere. Eventually, the temperature will burn up the spacecraft like a meteor before it's finally crushed by the immense pressure. Cassini's long list of achievements includes sending its Huygens lander through the thick clouds covering Saturn's mysterious moon Titan. As Huygens descended to Titan's surface, it revealed a world of flowing rivers and lakes, where it rains and where landscapes are sculptured and carved out by erosion. However, this seemingly Earth-like world is so cold, it uses liquid methane and ethane rather than water in its hydrological cycle. On Titan's frigid surface, water forms super-hard ice, making up the moon's bedrock. Cassini's also provided scientists with a new view of the Saturnian ice moon Enceladus, revealing its South Pole tiger stripes and geysers spewing liquid water high into space from a global subsurface ocean. Like the Jovian ice moon Europa, scientists are now speculating about the possibility of life in the oceans beneath the Enceladan ice sheets. This is SpaceTime. I'm Stuart Gary. The search for extraterrestrial intelligence has looked for many different signs of alien life, ranging from radio broadcasts to laser flashes, all without success. It seems the only thing approaching evidence of alien life involves the occasional probing of hillbillies. However, now a new study reported in the astrophysical journal Letters and on the pre-press physics blog archive.org speculates that the mysterious phenomena known as fast radio bursts just possibly could be evidence for advanced alien technology. As the name implies, fast radio bursts are extremely powerful but very short-lived blasts of electromagnetic energy, primarily detected at radio wavelengths. Lasting only a millisecond or so, these bursts appear to originate at cosmic distances, billions of light years away. First detected in 2007, less than 24 of these unexplained events have so far been detected, almost exclusively by giant radio telescopes like the Parkes dish in Australia or the Arecibo dish in Puerto Rico. Interestingly, they usually only occur once at a single location, and that's led astronomers to hypothesize that these could be the cataclysmic destruction of something, perhaps a supermassive star. The problem is, on at least one occasion, repeated fast radio bursts were reportedly observed originating from the same location. And if that's correct, it blows the cataclysmic destruction hypothesis right out of the sky. After all, how could you have fast radio bursts coming from something that's already been destroyed? The end result is that scientists really are still in the dark about exactly what fast radio bursts are. It was the great fictional detective Sherlock Holmes who's often credited with a logical fallacy. Once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. Of course, in reality, you can never fully eliminate all possible explanations for an observation. There'll always be something you hadn't thought about or some facts you simply weren't aware of. Still, Sherlock Holmes's logical fallacy can be used for a bit of fun. And that's where theorist R.V. Loeb from the Harvard-Smithsonian Center for Astrophysics comes in. He hypothesizes that these fast radio bursts could be leakage from planet-sized transmitters powering interstellar probes in distant galaxies. Loeb points out that fast radio bursts are exceedingly bright, given their short duration and origin at great distances. He says science has so far failed to come up with any possible natural source to produce them with any degree of confidence. So, for a bit of fun and as an exercise, Loeb and co-author Manasiv Lingam from Harvard University decided to determine what sort of artificial source would be needed to generate a fast radio burst. The pair examined the feasibility of creating a radio transmitter strong enough for it to be detectable across such immense distances. They found that if the transmitter was solar-powered, the sunlight falling on an area of a planet twice the size of the Earth should be enough to generate the needed energy. Of course, such a vast construction project is well beyond human technology. Nevertheless, it is within the realm of possibility according to the laws of physics. The pair also considered whether such a transmitter would be viable from an engineering perspective, or whether the tremendous energies involved would simply melt any underlying structure. And again, they found that a water-cooled device twice the size of the Earth could withstand the heat. Of course, that raises the big question, why bother building such a huge instrument in the first place? Loeb and Lingam claim the most plausible use for such power is driving interstellar light sails. The amount of power involved would be sufficient to push a payload of maybe 1 million tons. That's about 4 times the size of the largest cruise ships on Earth. And that should be big enough to carry living passengers across interstellar or even intergalactic distances. To power the light sail, the transmitter would need to focus a beam on it continuously. Here on Earth, observers would only see a brief flash. That's because the light sail, its host planet, the star, in fact the entire galaxy it's located in, would all be moving relative to us. Because of that, the beam would sweep across the sky and only point in our direction for a brief second. Repeated appearances of the beam might provide important clues about its artificial origin. Of course, Loeb admits all this work is purely speculative, a bit of fun. When asked whether he really believes that any fast radio bursts could be due to aliens, his response was to simply point out that science isn't a matter of belief, it's a matter of evidence. Deciding what's likely ahead of time simply limits the possibilities. So he says it's worth putting ideas out there and letting the data be the judge. This is Space Time. I'm Stuart Gary. Scientists are making a new case to try and restore Pluto's status as a planet. The team are doing this by proposing a new definition for a planet. The current definition was formulated after observations indicated there could be larger worlds existing beyond Pluto in the outer reaches of the Kuiper Belt. Following these revelations, in 2006, the International Astronomical Union agreed to define a planet as a body orbiting a star. It must be massive enough to be self-gravitating, in other words, it's got to be round, or relatively round, and importantly, it must have cleared out its orbit of other objects, except for any moons orbiting it. The new definition was developed because the solar system's then ninth planet, Pluto, was posing a number of problems, other than the fact there could be other Pluto-sized or even bigger worlds out there in the Kuiper Belt. Firstly, Pluto is absolutely minuscule compared to any other planet in the solar system. In fact, its diameter is just 3/4 that of Earth's moon. And secondly, it orbits the Sun in a highly elongated and tilted elliptical orbit, which is highly lopsided compared to the other planets. In fact, at one point, it's actually closer to the Sun than Neptune. Consequently, Pluto was relegated to a new class of bodies known as dwarf planets. The problem is this 2006 definition for a planet has been the subject of much scientific debate. You see, the definition has its own problems, and they're called Trojans. Trojans are asteroids which share a planet's orbit around the Sun, either constantly or they come in and out of the orbit occasionally. In fact, the Earth, Mars, Jupiter and Neptune all share their orbits with asteroids and Trojans at some point. But the new planetary definition being proposed by Johns Hopkins University scientist Kirby Runyon would increase the number of planets in our solar system from 8 to 110. Runyon claims, regardless of what one prestigious scientific organisation might say, Pluto is a planet. So he says is Europa, commonly known as the moon of Jupiter, so is the Earth's moon for that matter, and so are more than 100 other celestial bodies in our solar system that are denied this status under the prevailing definition of a planet. According to Runyon, Pluto has everything going on. Its surface is that associated with a planet, and there's absolutely nothing non-planetish about Pluto. Runyon led a group of 6 authors from 5 different institutions who combined to draft a proposed new definition of a planet, as well as a justification for that definition. All the authors are science team members on NASA's New Horizons mission to Pluto, which is operated by the Johns Hopkins University Applied Physics Laboratory. In the summer of 2015, New Horizons made history, becoming the first spacecraft to visit Pluto, sending back the first stunning close-up images ever made of this distant frozen world. Runyon and his co-authors argue for a definition of a planet that focuses on the intrinsic qualities of the body itself, rather than in external factors such as its orbit or other objects around it. They define a planet as a substellar mass body that's never undergone nuclear fusion, a classification which automatically has problems for brown dwarfs. According to the group, a planet also needs to have enough gravitational mass to maintain a roughly round shape, even if it bulges at the equator because of a three-way squeeze of forces created by its own gravity and the influence of both a star and a nearby larger planet. The proposed new geophysical definition omits stars and black holes. It also omits asteroids and meteorites, but it includes much of everything else in our solar system, expanding the number of planets from the current 8 to around 110. Runyon says the new definition is also more useful for planetary scientists. You see, most of them are closely affiliated with geology and other geosciences, thus making a new geophysical definition far more useful than the 2006 astronomical one. I'm Stuart Gary. This is SpaceTime. A new study claims the asteroid impact 66 million years ago, which led to the extinction of all the dinosaurs other than birds, also spawned a giant mountain range taller than what the Himalayan mountains are today. A report in the journal Science claims new computer simulations of the Chicxulub impact event showed that the initial rebound of the Earth's crust from the impact of a 10 to 15 kilometre wide asteroid would have temporarily produced what scientists call a ring peak, a mountain range within the crater. Similar structures are commonly seen in craters on the Moon, as well as craters on other bodies throughout the solar system. The Chicxulub asteroid impact event created a 30-kilometre deep, 100-kilometre wide hole in the Earth's crust, which then collapsed to form the 200-kilometre wide Chicxulub impact crater. Erosion through weathering and sedimentary deposits has erased most of the crater, which covered a massive area of Mexico's Yucatan Peninsula and the adjacent waters of the Gulf of Mexico. To scientists, the impact is known as the Cretaceous Tertiary or KT boundary event. That's because it marks the delineation between the Cretaceous period before the asteroid impact, when dinosaurs still ruled the world, and the Tertiary epoch which followed and eventually led to the rise of mammals, including humans. The KT boundary asteroid raised temperatures to over 5,000 degrees Celsius as it tore through the atmosphere, slamming into the planet at over 50,000 kilometres per hour. Hitting at an angle of about 30 degrees, its impact vaporised 1 trillion tonnes of Earth in a second. Any living creature within sight of the impact was killed instantly, either by the heat of the impact itself or by the colossal blast wave it generated. A tsunami several kilometres high was also produced, flooding the Americas, Africa and Europe. Within minutes, the impact sent a searing hot vapour cloud of poisonous gas spreading over America, setting the continent on fire and killing most life. Scientists believe that had the KT asteroid hit the Earth just about anywhere else, the dinosaurs probably would have survived, and of course humans would never have evolved. That's because the exact spot where the asteroid hit contained massive amounts of gypsum. As it was vaporised by the heat of impact, this gypsum produced a toxic mixture of chemicals, including sulfur dioxide and the greenhouse gas carbon dioxide. The sulfur compounds were especially toxic, forming little globules that persisted in the atmosphere for up to 100 years. The sulfur also mixed with seawater, which was also vaporised by the impact. This produced a powerful sulfuric acid rain, which then fell over the entire planet. At the same time, burning ejecta from the impact crater was thrown high into the upper atmosphere, eventually raining back down as fire over the entire planet and starting global firestorms. The dust from the impact and the smoke from all these firestorms combined to blanket the Earth, blocking out all sunlight and heat and creating an impact winter effect, which would have lasted for years. So, in addition to the shock wave, the tsunami, the initial firestorm, and the nuclear winter-type global cooling, the Earth and all life on it also faced being choked by thick clouds of poisonous carbon dioxide and being burnt by clouds of caustic acid. Of course, the KT boundary event impact didn't just affect the dinosaurs. It created the world's 5th mass extinction event, which killed some 70% of all life on the Earth. A dark layer of debris from that impact, rich in the element iridium, a very rare mineral on Earth but common in asteroids, marks the exact point in the geological history of the Earth 66 million years ago when the KT boundary event occurred. This KT boundary line is visible in rock strata across the entire planet, thereby providing indisputable testament to the global impact of this asteroid event. The new study by Professor Joanne Morgan from Imperial College London recreates the geological effects of this impact event in exquisite detail. To find out more, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Now they think it not only probably killed off the dinosaurs, it may also have been responsible for the creation of mountain ranges and who knows what other features on planet Earth.
It seems that it did make a mountain range higher than the Himalayas, which lasted about maybe 5 minutes.
Wow.
So what's happened is near the Yucatan Peninsula in Central America is the site of what we call the Chicxulub crater, which is actually barely visible, but there is evidence of a crater there. And that is, for many years, has been thought to be the site of the impact that wiped out the dinosaurs. And in fact, you can do that from, looking at the rock strata. The strata in which the dinosaurs disappeared is the same strata as this impact took place in Central America. So that's been fairly well established. Now, what is new is that the research team on a vessel equipped with drilling equipment, a research team has actually drilled deep into not the center of that crater, but something called the peak ring, which is the ring that's pushed up by the enormous pressures that the impact causes. They've drilled into that. They've drilled into it several kilometers. I think 4 kilometers was the depth, maybe 5. And what they're now telling us is what the results of that drilling are. And they are actually quite extraordinary. So the bottom line is it was about a 15-kilometer wide object that impacted there 66 million years ago. It punched a hole in the Earth's crust about 100 kilometers across and about 30 kilometers deep. That depression collapsed, leaving a crater about 200 kilometers across and a few kilometers deep. The central zone of the impact actually rebounded and then relaxed, and that's what gives rise to this inner ring. And basically, all this took place in the space of about something like 10 minutes. The headline piece of news is that there was this instant Himalayas were created. That's because the mountain range that resulted from this impact, even though it was very temporary, very, very short-lived, was actually higher than the Himalayas. And I think what it has underlined to the scientists who've been working on this is that because the pressures involved with this, the amount of energy being delivered to the Earth's crust basically behaved like a fluid. And what they've done is they've essentially simulated the impact in a digital computer, of course, with all the right stresses involved, the right amount of energy involved, the right toughness of the material on the surface. They've simulated that and really demonstrated that what you get at the end of it is exactly what you find in the Yucatan Peninsula. Looking at the core sediments, they've basically revealed that the granite of the material of the core there is shocked in a remarkable way. You know, on every scale, they say there are fractures in it. It's obviously gone through such a traumatic beating by this event taking place that it's really changed the structure. But what I think is most remarkable about this, and if any of our listeners want to head off to the BBC website, there's a simulation on there of what the impact actually did to the Earth's surface. And you can play that, and it plays for the equivalent of 10 minutes. It's speeded up. But you will be astonished at how that crater was created and what the flow of material was as that impact spread through the district. And of course, huge amounts of material were thrown up into the atmosphere at that time. The sun was darkened on the surface, the temperature dropped, and that's what killed off the dinosaurs, the ones that survived the shockwave coming from it.
Yeah, but I mean, you talk about the event lasting 5 to 10 minutes, but the aftermath of that was global cooling and darkening of the skies, as you said, and basically a blanket of death, really, that followed for perhaps months or years.
Yes, that's right. In fact, probably hundreds of years. One of the reasons for doing this drilling was to try and find out how soon life took hold again in the impact zones. And we haven't really heard much about that yet. What we've heard about is just the impact and the effect on the rocks of the Earth. And it is staggering. There's no two ways about it. When you look at the simulation that they've put, and it's in the form of a cross-section through the Earth's crust, when you look at that and you see the distances that are involved, we're talking about tens of kilometres here. And yeah, the surface is just ripped up. It's just as though it was a liquid, exactly as though the surface was a liquid.
It just makes me wonder what might have happened to the life that existed in the general vicinity at the time. I mean, would it have just been evaporated off pretty quickly?
I think so. Anything nearby, and I guess that's within a few, probably a few hundred kilometres, there would have been such a shockwave that the pressure would have probably killed everything. Very, very significant event. I mean, something that size, 15 kilometres, it produces global changes.
Wow, okay. And all that from just drilling a 4-kilometre hole. You just get so much data with the technology these days. Digging up a few rocks, that's
exactly right.
Obviously more complicated than that, but that's basically what we're doing.
Yeah, and so it's this combination that science thrives on. It's a combination between the observations that you can make and the theoretical models that you can build because you know how physics works. And when the two come together, look, everybody's very happy. Actually, they're happy when they don't come together as well, because that means you got your theory wrong. You've got to start thinking about it again.
Yeah. Well, I think we call that trial and error.
Trial and error, that's right.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. A Delta IV rocket has successfully blasted off from the Cape Canaveral Air Force Base in Florida, carrying a new military satellite into orbit. The United Launch Alliance's first Delta IV mission for 2017 took off from Space Launch Complex 37, carrying the US Air Force Space Command's wideband global SATCOM WGS-9 telecommunications satellite. The evening launch had been delayed slightly by swing arm problems with the service tower. The Delta IV launch vehicle was in its medium +5-4 configuration, using a single core stage equipped with an aerogel Rocketdyne RS-68A liquid-fueled cryogenic engine burning liquid hydrogen and liquid oxygen, and 4 strap-on GEM 60 solid rocket boosters.
Status check. Go Delta. Go WGS-9. Green board. Flight locket. SRM TVC blowdown.
15.
Rough ignition.
T-minus 10, 9, 8, 7, 6, 5, 4, RS-68A engine ignition, 1. And we have liftoff of the United Launch Alliance Delta IV rocket carrying the WGS-9 mission for the United States Air Force. What a great way to celebrate the Air Force's 70th birthday.
At full thrust, SRM burn profile is also looking good. SRM chamber pressure is beginning to tail off of max pressure.
You are hearing the voice of Patrick Moore providing launch
Mach
vehicle
1
ascent
Delta IV is
data.
now supersonic. Now passing 46 seconds, max Q, maximum dynamic pressure. Vehicle traveling right down the middle of the range track, looking good. RS-68 engine operating parameters continue to look good. Now passing 1 minute into flight, approximately 30 seconds remaining in the solid rocket motor burn. SRM burn profiles continue to look good. Vehicle traveling right down the middle of the range track. Delta IV is now 14 miles in altitude, 32 miles downrange, traveling at 2,200 miles per hour.
After launch, the solids flame out after 100 seconds of flight, while the core stage continues to burn for just under 4 minutes before MECO or main engine cutout.
Standing by for SRM burnout shortly. And we have SRM burnout standing by for solid rocket motor jettison. We have good indication of jettison of all 4 solid rocket motors. 1 minute, 50 seconds into flight. Delta IV rocket now weighs just 1/2 of what it did at launch, burning propellant at a rate of almost 2,000 pounds per second. Upper stage ACS press valve has been opened. ACS tank is now pressurizing to flight levels. Vehicle now passing Mach 5. Delta IV is now 39 miles in altitude, 90 miles downrange distance, traveling at almost 4,000 miles per hour. RS-68 continues to perform well. Fuel injector and chamber pressures look good. Vehicle continuing to travel right down the middle of the range track. Upper stage lock system has begun the boost phase chill down sequence to begin thermal conditioning of the RL-10 engine. 1 minute to BECO. And we've begun the upper stage boost phase chill down for the LH2 system, standing by for payload fairing jettison. And we have good indication of payload fairing jettison. RS-68 continues to perform well. Fuel injector and chamber pressures look good. 3 minutes, 30 seconds into flight. The vehicle guidance system has stopped active guidance in preparation for BECO, standing by for booster throttle down shortly. And the booster has begun to throttle down in preparation for BECO. And we have BECO booster engine cutoff standing by for stage separation. We have good indication of stage separation.
The Delta IV upper stage then ignited 13 seconds after first stage separation for the first of 3 burns from its RL-10B2 cryogenic engine.
We have pre-start, ignition, and full thrust on the RL-10. Vehicle body rates damping out nicely from initial startup transients. This is the first of 3 planned burns for today's mission. This first burn should last approximately 15 minutes and 30 seconds.
The mission's WGS-9 payload was deployed after the second engine burn just 42 minutes into the flight into a supersynchronous transfer orbit with a perigee of 435 kilometres and a 44,372 kilometre apogee. A third engine burn was then used to deorbit the upper stage as part of plans designed to reduce the amount of space junk orbiting the Earth. The Boeing WGS-9 spacecraft is based on a BSS 702 platform. It's equipped with a phased array antenna to provide 8 jam-resistant X-band beams and a further 10 individual Ka-band antennas. The satellite carries enough fuel for a 14-year lifespan and will provide global flexibility and high data rate and long-haul communications capabilities for the United States military, the White House Communications Agency, the US State Department, and key American allies. In fact, the WGS-9 satellite was jointly funded by a 6-nation consortium, including Canada, New Zealand, Denmark, Luxembourg, and the Netherlands. They joined the Australian Defence Force, which has already independently funded one of the spacecraft in what will eventually be a 10-satellite constellation. As well as the first Delta IV flight for the year, it was also the 35th launch of a Delta IV rocket. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.